Section E is having a 5-mark question, and section A will contain 3 questions of 5 marks each. These questions can either be asked in 2 parts or in 5 subparts. Here is a question which is having a 5 subparts, and we can answer one by one. This question from the unit D and F block elements. So first subpart of this question is explain the observation. Although zirconium belongs to 4D and hafnium belongs to 5D transition series, but it is quite difficult to separate them. Why is that? Or we can ask this question like that. The elements of 4D series and the element of 5D series are difficult to separate. Or the question can come in other way around. There is a difference in 4D and 3D elements in their atomic sizes, but the atomic size of 4D elements and 5D elements are similar. So the reason is due to lengthened contraction, the element of 4D and 5D are having a similar atomic radii, and they are having a similar chemical property. So either although they are belongs to 4D and 5D, because of the similarity or having almost same atomic size, it is difficult to separate them out. So let's write the answer for A subpart, that is zirconium of 4D and hafnium of 5D are having similar or same or approximate same atomic radius or radii due to lengthened contraction. Due to lengthened contraction, they have same chemical properties. So difficult to separate these elements. So ये रीजन हो गया है, बिकॉज ये क्वेश्चन जो है वो 5 सब पार्ट्स में है. सो we will write the answer precisely according to the weightage. 1 पर मार्क्स सभी को सब पार्ट्स के लिए असाइन है. The second part is why obtaining oxidation state greater than 2 for copper is difficult. Copper can be exist in a +1, which is a very unstable, or the most stable state is +2. Because to remove third electron, it requires a huge energy. So it required a very big amount of ionization energy for third oxidation state. That is why the +2 oxidation state is more stable. So यहाँ पे हम इसका आंसर क्या लिख देंगे? Because third ionization enthalpy is very high for copper. So it is difficult to get oxidation state higher than plus 2, or you can write the 2. Clear? Then the third subpart is this. While chromium oxide is a basic in nature, while this chromic oxide is amphoteric. So what is the reason behind it? Chromium is showing plus 2, plus 3, plus 4. In lower oxidation state, it is behaving as a basic. And in a higher oxidation state, it is behaving as an acidic. But when the oxidation state is not high, not low, it is behaving as a amphoteric in nature, means it is reacting with the acid as well as a base. So for this we can write like this: why the chromium, so chromium oxide is basic because here the oxidation state is lower, while in higher oxidation state it behave like acidic, but in moderate oxidation state is that plus 3, it is amphoteric in nature, ना ज़्यादा हाई है ना ज़्यादा लो है. So for 3 subparts, these are the answers. Just have take a screenshot so that I can move to the further questions. Okay. So the next question is or subpart of a 5-mark question. And if you have any doubt, you can give me a comment in my comment box. What is the reason behind what is the reason behind the unique behavior of copper in aqueous solution? In aqueous solution, copper is available in a plus 2 oxidation state because while it is coming or showing plus 2 oxidation state, the hydration enthalpy is more and the high charge density on the copper ion make it stable, and this is a while it is going to plus 2 oxidation state, the reaction is exothermic in nature. So how we will write the answer for D subpart, that is in aqueous solution copper is available in plus 2 oxidation state, which is more stable because of high charge density and hydration enthalpy. Hydration enthalpy is high and reaction is exothermic. So this is the unique behavior for a copper in aqueous solution. The last part of this question is, out of manganese at third ionic stage and chromium at third ionic stage, which is more paramagnetic, and if we are choosing any, then we have to give the reason for it. So let's write the first oxidation state +3 and electronic configuration for manganese at ground state. What is the atomic number of manganese? That is 25. Sometimes it is given in the question कि manganese का atomic number जो है that is 25. Otherwise at least 3D series के जो 10 elements हैं we should remember the atomic number, याद होना चाहिए. तो 25 है. ग्राउंड स्टेट पे इलेक्ट्रॉनिक कन्फिगरेशन आर्गन 4s2 3d5, ये ग्राउंड स्टेट पे इलेक्ट्रॉनिक कन्फिगरेशन है. एट थर्ड आयनिक स्टेज व्हाट वुड बी द इलेक्ट्रॉनिक कन्फिगरेशन? आर्गन 4s0 3d4. 2 यहां से ले लिए, एक हमने 3d से ले लिया. And the second is chromium third. Chromium atomic number 24. So chromium का ग्राउंड स्टेट पे इलेक्ट्रॉनिक कन्फिगरेशन लिखते हैं, दैट इज 24 and it will be argon 4s1 3d5. एक्सेप्शनल केस है, होना क्या चाहिए? 4s2 3d4. But as we know, half filled, full filled and empty are more stable. So in order to get the stability, the electronic configuration is 4s1 3d5. At third ionic stage, what would be the electronic configuration? Chromium 3 plus, आर्गन 4s में से एक निकाल देंगे 0 एंड 2 अब हम डी से निकालेंगे 3. फॉर Mn 3 प्लस डी में कितने इलेक्ट्रॉन है? 1 2 3 4 5. ये 3d है. 1 2 3 4. क्रोमियम के लिए थर्ड आयनिक स्टेज पे हाउ मेनी इलेक्ट्रॉन्स आर अवेलेबल इन डी? 1 2 3 4 5. ये 3d है. 1 2 3. Out of these two, which is having a more number of unpaired electron? क्योंकि जो मैग्नेटिक बिहेवियर है, we can calculate root and n+2. तो जिसके पास ज्यादा होंगे वो ज्यादा पैरामैग्नेटिक इन नेचर है. So out of these two, Mn 3 plus is more paramagnetic. And why? Because it has 4 unpaired electrons. उसमें 3 ये दोनों ही पैरामैग्नेटिक है, बट ये ज्यादा है. If you have still any doubt, just give me a comment in my comment box. See you soon in the next video and don't forget to subscribe my channel for the coming new updates.